Isolated system versus closed system. Isolated system. An isolated system can be understood as a closed system itself. Closed systems are those systems in which the matter is not able to pass through the boundary. In an isolated system, energy cannot pass through its boundary. In a closed system, the energy of the system is able to pass through its boundaries. An isolated system is a theoretical concept. There is no such system that shows an ideal isolated system. Closed can be found in the real world. The entropy change of an isolated system never decreases. The entropy change of an isolated system can decrease. Isolated system versus closed system. Let us diffusely discuss the comparison between an isolated system and a closed system. An isolated system. An isolated system is oneself a manifestation of a closed system. An isolated system is non-identical from a closed system, as a closed system have a thermal or mechanical contact with its adjoining. This means that an isolated system cannot exchange either matter or energy from its surroundings. And additionally, isolated systems acquire thermodynamic equilibrium with a setup by balancing the temperature, pressure, or other parameters. However, in reality, an isolated system does not even exist. Because in the universe, each and everything interacts with one another in either of the ways. But even though our universe can be considered an isolated system, as we know that in universe, there is no transferring of matter and energy with any other universe. Practically it is not available, but it is used theoretically for constructing models. For instance, the first thermodynamic law and second thermodynamic law explain an isolated system. The first law of thermodynamics states that the internal energy of an isolated system is constant. The second law of thermodynamics says that the entropy of an isolated system increases in the course of a spontaneous process. Where these two laws are only applicable for isolated systems. The system's entropy will exceed over a period in an isolated system and will reach its zenith value at the equilibrium. Hence we are able to say here that the total energy is not going to increase for isolated system, and in the consequence to it its entropy will never decrease. A closed system. In a closed system, the matter remains constant, but its energy can be exchanged or transferred from the system to its surroundings. So, in a closed system the matter is circumscribed and remains constant. But the energy of a closed system can swap with its adjoining. For instance, while a reaction takes place, the system gets expanded, or we can say that it can transfer its energy from its surroundings if its temperature is low. When we cover the cup of hot tea with a lid, it becomes a closed system. Because the steam from tea is trapped between the cup and the lid on it. And in addition to this, the molecules in attendance in its adjoining do not set foot in the cup. Hence, there is no exchange of matter. However, the heat dissipated from the tea gets exchanged with its surrounding. We can understand it when we touch the cup and lid and feel hot. So we can say that the energy which exits the system is a thermal energy. Here, the system acquires an equilibrium with its surrounding. This happens because the temperature of the tea in the cup and the temperature out of the system get same. Second example of a closed system can be taken as a battery. However, it will seem like an isolated system because its internal matter is sealed. But if we consider the charge of the battery. In this, during the charging of a battery, the electrical charge flowing through the battery comes to an endpoint and dies. This flow of charge shows the transfer of energy, but the matter in a closed system is intact. This defines battery to be a closed system. Now let us consider an example of an isolated system, however it is difficult to find in reality. Because there is no ideal isolated system found till now. But still, the closest example of an isolated system is a thermoflask. Because if we put something hot in a thermoflask, due to insulated walls of thermoflask and the tight lid on its top, do not allow the heat energy to dissipate. Any hot material, say any fluid in thermoflask, remains hot for several hours as the thermoflask stops heat transfer through any medium or way. Either it is conduction, convection, or radiation. Here isolated system can easily be pictured and now understood as a thermos where the fluid system remains hot. It does not transfer any heat energy, nor is its matter exchanged from its surrounding. On the other hand, a closed system can be assumed as a sealed jar, where the material inside it changes its temperature as it transfers the heat from its surrounding. This means the energy can either enter the system or dissipate out from the system. Accordingly, we are able to say that, in an isolated system, energy do not get swamped and matter too do not swaps from the surrounding. Whereas in a closed system, there cannot be any exchange of matter, but the energy can be exchanged. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.